Welcome to the Aspire Technology Governance rApp demonstration. AI-powered RAN performance, anomaly detection, activated through VMware centralized RIC. As communication services providers, or CSPs, embrace RAN programmability to onboard networking transforming technology, one of their most critical daily operations is the management of the changes introduced in the network by the newly deployed RAN applications. Operating mostly in isolation, these applications apply modifications that impact RAN's performance and may result in anomalous network behavior if not conducted properly. So how can CSPs control these changes and quickly detect any anomaly before it's too late? Aspire Technology's Governance rApp, powered by VMware centralized RIC, uses AI and machine learning to detect RAN KPI anomalies due to applications changes, while enabling configuration management corrections to ensure that the RAN performance is switched back to its expected level. The business impact is instant. Using Aspire's Governance rApp, CSPs can obtain immediate feedback on the RAN application's performance and use that information to optimize their behavior. They can simplify development and onboarding of the RAN applications by offloading complex monitoring operations to the Governance rApp. Finally, thanks to Aspire's rApp, CSPs can quickly intervene in case of RAN anomalies and avoid costly network parameter rollbacks. So how does Aspire Technology's rApp work? The main modules of the rApp are the Data Pre-Processing module, which includes the amalgamation and reformatting of the streamed performance management data. The AI/ML Detection module, which groups the KPIs based on their statistical characteristics and applies the corresponding anomaly detection algorithms to each group. A MySQL database that stores the process data. And finally, a web app that displays the results to the user. The AI/ML Detection module organizes the KPIs into two groups. The Stable KPIs group, composed of KPIs that remain almost constant over time, such as packet loss, and the Variable KPIs group, comprising KPIs that change over time, such as latency. To detect anomalies, the rApp periodically requests PM and CM data from the RIC and applies the corresponding detection algorithm to the performance KPIs. For the Stable KPIs group, the algorithm compares the measurement to the 99th percentile of the historical data, while for the Variable KPIs group, the Generalized Extreme Studentized Deviate algorithm, or GESD, is used to detect an anomaly. Issues are automatically resolved through CM corrections. Let's now see Aspire Technology Governance rApp in action. Our testbed is composed of the VMware centralized RIC, offering R1 exposure, data management, AI/ML, and A1 services to the application. Then, and integrated through the VMware SDK, we have Aspire's Anomaly Detection rApp. Lastly, our testbed is completed by two datasets emulating RAN functions and reporting performance and configuration data to VMware centralized RIC and Aspire rApp. Let's activate this testbed. Through the command line, we can easily activate Aspire Governance rApp with just a few steps. The logs show the communication between the application and the VMware centralized RIC over the R1 interface. We can see how the application is already receiving performance and configuration management data. Now let's evaluate Aspire rApp's anomaly detection capabilities. The emulated environment is composed of 36 sites with a total of 50 cells and 11 KPIs evaluated. Aspire's Governance rApp GUI shows a summary of the network-wide anomalies and a map of sites located around the city of Dublin, Ireland. The red circles indicate anomaly detection on at least one of the monitored KPIs in that site. Using the rApp's front end, we can zero in on the issues detected and filter by the date, by site, and by KPI. By clicking on a site, a window reveals which anomalous KPIs have been detected. In the case of site 0281, the rApp is reporting unexpected values for downlink packet loss and uplink throughput. We can now zoom in on the site and access the KPIs page, where we see graphs of the performance of all 11 monitored KPIs, and with red indicating anomalies and green indicating adequate performance. We can see that for KPI downlink packet loss, the rApp reports an anomaly. A closer look tells us that there was a sharp increase in packets lost at 1:05 a.m. and another one at 2:05 a.m. The rApp can then use this information to evaluate CM changes and kick off the remediation process. To summarize, in this demo, we have seen how Aspire Technologies' Governance rApp immediately detects anomalies in network's performance caused by RAN changes to quickly activate remediation. Using Aspire's rApp, powered by VMware Centralized RIC, CSPs can apply centralized governance to optimize RAN performance, improve resiliency, and fast-track onboarding of new applications and technology with the reassurance that customer experience will never be impacted.